So today, I'm extremely lucky to be on stage with an extremely diverse panel. We have e-waste, we have aluminium waste, as well as plastic waste. पूरा waste यहाँ पर मेरे floor पे है. So, good afternoon, everyone. We are about to discuss something that is extremely important to the Indian manufacturing ecosystem. We just can't keep importing things, right? We have to understand how to make it a circular economy. India is the world's third largest producer of e-waste. We import almost every critical mineral that is out there and worth billions of dollars. But how can we change that equation? And that's what this panel is about. So I'll quickly introduce my panelists. I have Mr. Nitin Gupta, co-founder and CEO of Atero Recycling. Nitin and I had met probably 6 years back at multiple EV events, and just 2 days back when we were talking and we realized we had already saved each other's number. Nitin has been there in the ecosystem for over 10 plus years talking about advanced e-waste recycling. He is an IIT Delhi alumnus with an MBA from NYU Stern and London Business School. Nitin do cover your patents as well as your work on doing on materials and also your ongoing work with the government.
Should I start? Or you
yes, please. We'll just go with
First
that.
of all, good afternoon, everyone. Ayushi, thanks for having us. I think it's the current times that we're living in are pretty interesting, right? So I keep joking internally and at least to my 2 young daughters as well. Our generation has been very lucky to see 3 changes of technology. We have seen telephony when we had to make a trunk call and also pay collect charges, right? And then to the mobile phone telephony, then to the internet, and now the AI age. So significant technological change and innovation is what we have seen as a generation, and typically don't see that even one change across many generations, right? This has also created a lot of value creation, like Mr. Ajay was saying earlier on. How can innovation lead to basically creating a lot of shareholder value or value for the planet or value for individual, whatever you might want to term it as. From a materials perspective, the sort of passion that we had when we started Atero was essentially to look at a new world paradigm, to say mining is among the most polluted industries in the world. Is there a way in which we can replace, substitute even a percentage of mining, right? That is the original thought process with which we sort of ventured into looking at how do we do Atero or what do we do from a starting standpoint. So from that context came that technology is extremely critical, innovation is extremely critical to be able to do something and come out either with new materials or look at existing materials and figure out a way to extract them in a better manner rather than get things wasted, right? First, we started with electronic waste. We developed the technology in India. Today, we have 55 plus granted global patents on various recycling technologies developed by us in India. Patents are across US, Europe, and Asia. The best technology for electronic waste in the world, the best technology for battery recycling in the world, where we extract more than 22 plus critical minerals by recycling all kinds of inputs, electronic waste, lithium and batteries and magnets. What we extract is ranging from, let's say, precious metals like gold, silver, platinum, palladium, to base metals like copper, aluminum, tin, zinc, to battery materials like lithium carbonate, cobalt, nickel, graphite, and to rare earth materials like neodymium, dysprosium, praseodymium, and others, right? From an India-specific perspective, India is, like Ayushi was referring to, at the crossroads today from a geopolitical angle. We are a net importer of almost every single metal, and we are completely dependent on an import for every single metal. The secondary economy, or the urban mining as we call it, is an important source of these metals. We fundamentally believe that by completely using recycling as a process, India can meet at least 20 to 75% of its demand, depending on the metal that you speak about. For copper, it's let's say 20%. For rare earths, 75%. By building a proper recycling infrastructure, the technology for which exists, and scale is what is required at this point in time.
Thank you. Thank you so much for that. Then going next to Mr. Rajat. Aluminium, I can guarantee, is right now on each one of you over here. It may be your smartphone, it may be any electrical item out there. Rajat is the managing director of Pearl Alloys, a leading aluminium alloy manufacturer established in 2000. Rajat, do talk about your company, your consumers, as well as how you're changing the larger manufacturing ecosystem and the larger innovations in it.
Hi, good morning, everybody. And thank you for inviting us to Chhatrapati Sambhajinagar for this amazing conference in front of such amazing audience. So kudos and cheers to you guys for making it today. As we speak about aluminium and one of our companies, Pearl Alloys, which is recycling aluminium, we are basically into recycling of all sorts of aluminium scrap. But interestingly, that's not how my career started. I started as a media tech company, manufacturing DVDs and CDs, and later also launched India's first music streaming service. Even though we were too early for it, but it was a lesson learned. That is when my father, we were almost struggling in one of our businesses, which is the aluminum recycling. It was a 50 crores annual revenue when he asked me to, take it over. And it was definitely a commodity business. And as we all know it, aluminum in the end is commodity. But specialization, we found specialization in commodity, and how I met more of our clients, we realized that die casting, most of my clients are die casters, and we found that die casting has a problem, and a real problem is rejections, right? Rejections due to porosity, overflow, and many other problems, And that is when we decided that what can we contribute to lower down their losses. And, working with veterans of the industry is when we started solving their problems, our materials started giving them lesser rejections. And when I saw this picture, I was laughing, So as they say in US, I was laughing to the bank. So luckily, we've been able to go from 50 crores to 1,500 crores today. And with contracts and pipelines going up to about 5,000 crores in the next few years. So recycling is amazing. It is where fortunes can be made. And also not to forget, while you make fortunes, you're creating immense value for your country, for your society, because that waste would either end up in landfills, would either go into the water you drink or the food you eat. So recycling that way is also an amazing and very, very satisfying business as a whole, and I would also encourage more and more of you, if you can, take up one field and excel in it. Thank you.
Thank you so much. Thank you. So next, Mr. Vishal. This morning, I had the privilege to talk to him about what he's doing on ground, and I would like to start off with something which Dr. Uday actually did say. AQI in Delhi is actually 1,500 plus, easily. I am asthmatic myself, and I remember I have my 4-year-old son. Last year, I went to the doctor, and she said, "Isko kuch nahi hoga. He is born in Delhi, and he will be fine. Inski lungs hi aisi evolve ho rahi hai. Versus me, you will have to take your inhalers. You're not going to evolve. This is who you are." The reality is, we are the generation who are causing the issue, but we are the generation who will solve this issue. So Mr. Vishal Mehta is one of the most critical elements here, which is solving the issue of wood. It may be paper, it may be your furniture, it may be almost any component in your life. There is a part of wood, trees, basically. He's the co-founder and CEO of Unwood. They are an innovative manufacturing company with a breakthrough material created with wood from plastic waste. Yes, from plastic waste. This tackles two environmental issues simultaneously. So, of course, plastic as an issue as well as deforestation. Plastic clearly is not going away soon, so there will be a component, but how do we recycle it? I will let Vishal talk more about this.
Yeah. Jai Jinendra. I'm very happy to come to this city. Actually, it holds a very close space in my heart. My father has grown up here. He's done his engineering here. So he always keeps talking about now Chhatrapati Sambhajinagar, earlier Aurangabad. And I've seen the growth of this city through his visits here and our visit here. So really happy to come here. I'll just quickly take you through my journey. So when I graduated in engineering, I was aware that India was importing 90% of its crude oil. And I wanted to do something to make India energy sufficient. So I joined L&T, and I was in the hydrocarbon division. So I was working to set up mega projects in the sea to explore oil for India. And I thought that, I will be contributing to nation building. But working 9.5 years, I understood that we are growing, our need for energy is growing, and oil is not going to satisfy it completely. So I moved to renewable energy. I joined a European MNC to set up new renewable power plants in India, mega scale, solar plants, wind farms, did that for 7.5 years. When I imported a lot of solar panels, created a huge amount of waste, I understood that the real problem is sustainability in how we use materials, how the materials are explored, how they are processed, how energy efficient is their processing and manufacturing, and how is their disposal. Most of these materials become pollutant. Even wood that we use, we are cutting large amount of trees, and we continue to cut trees to use wood as a material. Something was wrong in material space, and I was exploring deep tech solutions to material science, and that was the initiation and birth of Unwood when I met Dr. Babu, who you heard before, and we co-founded Unwood.
Awesome. Thank you so much. So let's just start right away. Isme paisa hai kya? That's what, as a Banya, as a Jain, you ask. Right, this is all great, but can you make money? Are there margins? So starting with you, Nitin, you want to invest over $1 billion into this. Can you talk a little more about battery recycling, e-waste, and what are investors looking for, and what does the whole model look like?
Well, Ayushi, there is a lot of money to be made in recycling today. Largely because the macro factors are pretty well aligned globally, not only in India. Specifically, if you look at lithium-ion battery recycling, essentially the entire energy transition macro theme that's playing out is premised on battery as a storage. Within that, lithium-ion is the best battery technology, largely because it's got the highest energy density. And by that I mean is, in the smallest form factor, how much energy can you store, right? Imagine if you replace your cell phone battery from lithium-ion to lead acid, your cell phone size will typically become 4x, and you'll not want to carry it, right? So energy density in lithium-ion batteries is best by far. It's got the fastest charging time and the slowest discharging time. But more importantly, close to around $200 billion have already been deployed in the lithium-ion ecosystem globally, and many more continue to get deployed. The outcome of that is that lithium-ion batteries are now ubiquitous in our lives, starting from consumer electronics to energy storage solution packs to, let's say, EVs, right? What this also means is that the amount of end-of-life lithium-ion batteries is also growing exponentially and needs to be treated in an environmentally friendly manner. Combine that with the fact that almost 42% of the cost of a lithium-ion cell is the cost of raw materials that make it up, which include cobalt, lithium carbonate, nickel, and graphite. Each of these critical battery materials has significant ESG issue or sustainability issues. Cobalt, for example, 70% of the cobalt is mined in Congo, which is driven by child labor, terrorist regimes. 60% of lithium comes from the Brazil, Bolivia, Argentina region, which is water-starved. It's got significant geopolitical issue. China today controls more than 80% of the world's critical mineral supply chain. It does not mine, it's built significant refining infrastructure, plus it's a supply chain issue, right? So recycling of batteries sits in the center of both of these global macro themes playing out. There's huge supply and there's huge demand, right? The only challenge is technology. How can you efficiently extract all these metals in the same form that is used as from virgin mining, for example, and how can you do it cheaper, and how do you collect these batteries back, right? What we have built at Atero is various forms of technology, but we are extracting, let's say, 98% of pure battery grade cobalt, lithium carbonate, nickel, and graphite. Just from a context standpoint, globally that number is less than 80%. So for the same input, we are extracting 20% more revenue, We are doing it at a capex per ton, which is 40% lower than anybody else in the world. So yes, there's a lot of money to be made in recycling, right? Just to share some numbers, gross margin in a technologically, let's say, good battery recycling operation is more than 50%, right? Now, if you look at, let's say, magnets, and you're able to extract rare earths from there, again, China controls 99% of the rare earth market in the world today, right? Gross margins there are 80%, okay? So significant money to be made in recycling. From our own investment plans, we have been growing our revenue, doubling our revenue year on year. We are a profitable company, and we continue to invest more in building scale and infrastructure. So that $1 billion number is over the next 5 years. Part of it will come from internal accruals, part of it will come from project finance, part of it will come from equity raising.
Thank you so much. 90-80% margin sounds really, really nice. Going on to you, Rajat. You've started supplying liquid aluminium directly to customers. Can you walk us through the economics overall of the same versus solid ingots and the benefits that has to the customers and the business model?
Aluminium as a commodity, as an alloy for automotive component die casting companies, it used to be conventionally supplied as aluminium ingots, and they used to remelt the same into their furnaces and then supply their die casting machines in parts so that they could manufacture the components, And that's when we also questioned that why not supply them molten aluminum directly rather than they have to remelt our ingots. And of course, the savings are considerable. One is definitely the fuel cost, which they use in remelting. The second is the inventory holding cost, the space which frees up. So a lot of benefits, and the customers totally understand it. The challenges lied in India's infrastructure. How do you supply aluminium over, because in Germany or other developed nations, aluminium molten can be supplied over 400, 500, 600 kilometers at crazy, that's pretty crazy. But here you have a margin of about 7-8 kilometers max, okay? So that means that you need to build satellite plants near your customers. Those challenges, having smaller plant sizes and those satellite plants, how to feed them. But the savings are immense, and for us, the arbitrage here is that now we are not one of many suppliers, but we become the only, or maybe one or two max suppliers to the customer, and the business is more permanent and long term. Apart from that, we keep creating value with the customer once we are, totally hinged with them. So that way is aluminum supplying molten in molten form benefits both us and them in the long term.
Can you walk us through the economics a little in a minute, and then I'll go to Vishal?
Yeah, economics, you can say a bare minimum saving to the customer is about, on a kg basis, it's 350 rupees kg today. So aluminium remelting cost, a bare minimum saving to the customer amounts to about 12 rupees a kg. Our cost of additional supply of molten is about 4 rupees, which the customers usually are happy to pay. So 8 rupees a kg saving over an annual consumption of about, let's say, 10,000 tons amounts to almost huge amount of savings, So that ways, I believe that is a big saving from transfer, moving from ingots to molten, and that is how the industry will progress as the time goes.
100%. I would say every rupee counts. Mr. Ajay did talk about efficiency earlier, and that's what it is, right? Going on to Vishal, of course, Unwood is converting plastic waste, material which has negative value at least overall. But, there's a cost of money to disposal. I'm from Delhi, and both borders actually have large mountains of waste. My son tells me, Mama, wo mountain hai kya? I was like, nahi beta, wo kachra hai. So it's the reality of today. So can you talk a little about your unit economics and how does Unwood make money when it comes to this?
Yeah. So generally there is a misconception that because it is made from waste, it has to be cheaper. Actually, it's more expensive to process waste, rightly so. First of all, we have to understand that plastic is not one material. Plastic, even if you read the global notification, it is divided into 7 groups: PET, PP, HDP, LDP, ABS, and there is group number 7 which you write as others. Actually, this is a group of engineered plastics. Also, each category varies by melt flow index, polarity, heat cycles, additives added. So basically, we have created millions of materials in plastic. So the challenge is this kind of sorting segregation will not be possible. There will be mixing and there will be downcycling. Means the material that is recycled will never be reaching the virgin quality. It will always be lower quality and you will not get the price. So what we have done at Unwood is we focused on a deep tech solution to create a completely new material by homogenizing multipolymers. And this material has the strength of hardwood. So we are creating a new material with a property of wood from waste, and then we went one step ahead. This material is actually having better properties than conventional materials, including wood. It's termite proof, waterproof, and it can handle harsh environmental conditions. Creating a novel material, we created products, and we are in the outdoor industry from Kashmir to Goa with repeat orders with happy customers. So the value of the product became very superior, and that's what made upcycling possible. I no longer call ourselves as recycling.
Wonderful. Thank you. So next, let's go into, actually talking about how it's happening on ground. Nitin, coming to you, Attero has developed refining technologies, which you talked about, and all those, materials which you talked about, including lithium, cobalt, nickel, manganese that you are extracting. Can you walk us through how does it tie back to the EV ecosystem? Suppose if you could take an example of how the growth of EV is and how that will directly impact your ecosystem.
Yep. So it's directly linked, right? As the growth in EV happens, there'll be more consumption of lithium-ion batteries. So there'll be more end-of-life lithium-ion batteries. There'll be more requirement of treating them in an environmentally friendly manner. Plus, there'll be more requirement of raw materials to make these batteries. So by collecting these end-of-life batteries, recycling them, you're meeting 2 problems of killing 2 birds with the same stone, right? Supplying back raw materials, not mining them, substituting mining, which is an ESG positive activity, and also taking back waste and converting it back into sort of valuable materials. That's, I think, direct relation. But on that point, Ayushi, one couple of things I'd like to highlight here. Specifically from a lithium and battery recycling standpoint, today globally around 1 million tons of end-of-life lithium and batteries are available for recycling. That market is growing at roughly 30% year on year. 80% of that globally is coming from production waste. Now what is production waste? If you look at the cell phone, it's a single cell battery pack. If you look at the laptop, it's got 8 or 10 cells packed together. The EV has 400 to 1000 cells packed together. These cells are manufactured in gigafactories because they measure the capacity in terms of energy output. Every gigafactory globally has 10 to 25% of capacity as production waste, right? Today, roughly around 400 gigawatt of production capacity is there. That would broadly tie up to around 100 gigawatt of production waste coming out. And that's a low-hanging fruit from an opportunity standpoint. That is, you do not need to wait for EVs to become end of life. You don't need to wait to collect from post-consumers, all of that. It's directly coming from factories which are manufacturing this stuff. As long as you have the right process and technology to recycle it, you can build a big scalable business.
Great. Thank you. Thank you. So going to you, Rajat, of course you're importing aluminium scrap, right? Earlier we had talked about per capita consumption globally. Could you walk us through the larger global picture of where, aluminium consumption is and how that directly even relates to the price volatility that's happening in the market and how aluminium scrap overall makes it a attractive business for you to invest in overall?
Okay, so that's like 2 questions which you just asked, and both of them need to be addressed differently. Talking about how the aluminium consumption of the country is growing and which direction it's heading. So per capita consumption of aluminium in India is about 3 to 4 kg per person. Looking at US, they have a per capita consumption of aluminum about 15 kgs. World average is currently about 11 to 12 kgs. So even if India matches the world average, all right, for 3 to 4 to about 11 kgs in a decade, all right. There is immense potential in aluminium going forward. As we see, there is going to be automotive, look at the automotive companies. The projection for today from 4 million to 8 million passenger vehicles in the next 7 years is projected. We have about 24 million two-wheelers to be sold, and equally, so look at automotive, that's going to grow. Infrastructure, we have so many buildings coming up, infrastructure, airports, everything is shifting to lightweighting again in construction as well. And then talking about aerospace, India is going to grow in this sector and hugely. Aerospace itself is going to consume huge amount of aluminium, and going forward, even beverages, food, all of that. So going forward, we have a lot of potential going forward, about three times minimum in the next decade. So that builds a lot of opportunity for entrepreneurs, and they can choose their sectors on where they want to get into materials, metallurgy, or even, sciences around it. And when we talk about volatility, I would like to address, yes, India is an import-dependent nation for aluminium. We are still importing a large part of aluminium scrap. Even for that matter, a lot of scrap metals, we are still importing, because India is right now building, and those people are scrapping. So we are in a phase of building the country. They are in the phase of also building, rebuilding, and probably scrapping a lot. So we are importing a lot of aluminium per se, and that creates a lot of volatility, because today, if I book on a certain level of LME, US dollars, shippings, and then the geopolitical tensions, and by the end of 3 months, it takes about 3 months for the material to arrive, sometimes 3 to 4, all right? And the market scenarios have changed. So this volatility, I also see this as an opportunity, because the automotive OEMs also, address it to some part, but we reduce our risks through hedging, through local scrap procurement, and also we have developed technologies for converting oxides into, aluminum alloys, which has giving us a big arbitrage against the volatility across. So I would say a good mix of local procurement of scrap, whatever is generated, with the new scrappage policy, along with hedging and timing right. Timing the market right, you're able to keep yourself profitable, I would say.
Wonderful. Thank you for that. Going over to you, Vishal, you're using macromolecular fiber matrix overall. So that's sophisticated, hardcore materials science. Can you walk us through the commercial implications? How does unwood compare to wood or MDF? Talk about cost, talk about economics, as well as maintenance, right? Currently, you're focused on furniture. What does the overall story look like?
India, first of all, the scale of what we are doing. India is a growing population. About by 2047, 40% of our population will move to newer houses or better houses. They will need infrastructure. They will need furnishing. So we are looking already into the future. Now, when it comes to India's weather, we have variety of weather, right? From Kashmir to desert to coastal, huge coastline. There are a lot of harsh weather environments, and we need a lot of outdoor furnishing. So Unwood has currently positioned itself in this harsh weather. We have designed a material which lasts outdoor. Currently, people have started believing that I'm buying something for outdoor, this will last 2-3 years. They have accepted a replacement cycle. And Unwood products are lasting 3 to 5 times more in this outdoor environment. Our products are designed for 10 years plus life. This creates value for the customer and total cost of ownership. So even if the product is priced equivalent to the conventional products currently or slightly higher, over a life cycle, customers are very happy. I'll give you an example. The famous Aguada Fort in Goa. They bought our furniture last May, and they waited for an entire cycle of the season. The heavy monsoon, the summer, the salty sea air. And then they went ahead and gave us a repeat order, which is 5 times the order of the initial scale. So that is how we create value, and that's how the economics works for us.
Wonderful, wonderful. No, thank you for that. So going into our last segment on technology, starting with Nitin, you have over 45 plus patents with NASA, UN, FCC recognition for your technology at Atero. What's fundamentally different between for Atero versus other e-waste recycling companies? And critically, is this technology in India, is it importable? Is it something that one can, actually work with and scale across India?
Yeah, so bunch of questions there, Ayushi. First is, I just go back to the panel that we had earlier. At least in our case, we patent something after it's commercialized, right? We run a very dedicated R&D unit. That's the first thing that we did when we started the company. So let's take a step back, right? Life is a Brownian motion. There are many steps to success. I fundamentally believe innovation and technology and R&D are critical pillars of success, and that's how we started our journey at the company. And any patent that we do is after the technology is commercialized, right? So the 45 patents that you referred to is slightly older figure. Right now it's 55. We have more than 200 plus applied for globally, right? So all of those are innovations working on the shop floor in our case, right? Ranging from, let's say, how do you take a printed circuit board and make sure that you minimize the plastics going into the smelter from the printed circuit board, right? Printed circuit board is roughly 55% of weight by weight of plastics. If you feed that in the smelter, which is what, let's say, a Belgium-based electronic waste recycling company like Umico does, it's using more fuel or more energy. It's creating more obnoxious VO2 gases or more, let's say, pollution. And then you need to put a air pollution control system. It's got higher capex per ton. It's got higher opex per ton. How do you save that? By doing an innovative mechanical pre-processing step. That's one patent that we have as an example, right? Another one, for example, in the battery recycling domain, the way that we extract lithium carbonate in the last process is using a process known as precipitation. Very simple, right? This is a bottle of water. If assume it's got sugar mixed in it. If you want to replace sugar with salt, we put salt, sugar will displace and salt will get mixed with it. In our case, lithium carbonate comes down in the precipitation process and it's getting displaced by some other chemical process there, right? Lithium carbonate has precipitation limits of 50%. So we have modified those precipitation limits by changing the operating conditions to make it 98%. Nobody in the world has been able to do that till now, neither the Chinese guys nor the US guys, right? And capital is not the only constraint there. In battery recycling, over the last 24 months, roughly $5 billion equity dollars have been deployed. Large part of that capital has gone to US and China, right? Still our technology is the best. So it requires a certain amount of perseverance, gut, passion, all of it. Take whatever name you want to do it, but there has to be some sort of junoon to come up with what you want to come up with, right? So two examples there in terms of how innovation works. Then innovation in supply chain. So that is innovation on the shop floor, but then how do you collect these materials? So in our case, we started 2 digital platforms. One platform is called SellSmart. SellSmart is basically you can go online, put your home address and we'll pick up your washing machine and pay you the best prices for it, right? To do that, there's a lot of innovation in reverse logistics. There's a lot of innovation in pricing. Like Rajat was mentioning earlier, in commodities, pricing fluctuates globally, right? The US price fluctuates, the UK price fluctuates, the Indian price fluctuates. What we have built is at the back end of 2 digital platforms that we have is an AI-based pricing engine, which takes prices of various commodities globally, converts them on a real-time basis into the domestic Indian price, with factors varying from GST to various import duties to local supply demand to what's happening from a macro-micro perspective, and puts out these pricing on both of these platforms, so Metal Mandi or SellSmart, on a regular basis, right? And then how do you make sure that you pay the best price for the scrap collectors, right? So let's say if a compressor is comprised of copper or aluminum, the price is different. So by just looking at it from a vision perspective, can you automate that process, right? So one of the technology innovations that you've done is by just looking at a picture, we can say whether it's a copper compressor or an aluminum compressor. And we don't need to go through a physical verification process, right? So innovation and technology plays a role across supply chain, across shop floors, and ultimately helps in business.
I'm very happy you brought up AI. AI is becoming very central to all our lives, and it will be an important component going forward. And fully agree to the fact that Junoon, and I would say Jugaad and patience are three things you need, along with technology and AI, to actually scale anything in this world.
And luck. Without luck, nothing happens.
Absolutely, absolutely. Rajat, I'll ask you a question that's more of a mix of innovation and manufacturing. So, as taking an example of an automotive company that's say at 150 crore revenue, making die-cast parts, they are currently at 30% recycled aluminum and want to go to 70%. What is stopping them from making this transition? What are the ongoing issues that are happening?
Adding more scrap sometimes also puts a pressure on the quality of the product. So you could increase the percentage of scrap, but it could also affect various other characteristics like the microstructure, flowability, or viscosity of the molten metal, which would cause defects in the components. That's one of the key reasons, but we are working very closely with OEMs. There was a belief that the aluminum wheels should only be manufactured from virgin aluminum, but now with the ESG guidelines across Europe, US, and the Paris Climate Accord, every car should have a minimum of 35% of aluminum or recycled materials, if they want to do business with Europe. So even wheels, now we are working closely with the OEMs that they will be as strong or maybe stronger with all the testings and everything, but even with recycled materials, all right? Apart from that, I want to take a lead from Vishal about AI, as aluminum scrap, this I'm adding to your question, okay, so to technology. A lot of AI scrap is, aluminum scrap is totally non-uniform. You don't have any way to identify, like plastic granules that totally uniform. Every granule looks the same. So this is like something is a car engine, something is a compressor body, something is a motor body, something is a construction, and lots of something is aerospace. So scrap comes like from all mixed, all right? So there is immense value in segregating scrap the right way, all right? And segregating, now what we are implementing is AI-based, recognition through X-ray sorting, okay? So X-ray sorting is, I believe, the future in sorting materials so that you are able to get the best value out of that scrap, all right? You may be able to make high-value alloys out of the high value scrap, and you're able to segregate it to that level that you're able to profit, because when you buy at a normal level, right, at the price of a scrap. But inside that scrap, there's a lot of value inside, and identifying those through AI is going to be a big frontier for recycling in aluminum in the future. Thank you.
Wonderful. Thank you. Thank you. And last question for Vishal, and then we'll open the floor. Vishal, of course, Anbud uses this beautiful technology developed by Dr. Babu. So I have two questions for you. How do you ensure consistency when it comes to working with variable plastic waste streams? And lastly, you've chosen a very innovative way to go to market when it comes to this technology. Can you talk a little about that as well?
Okay. So I already told about how plastics are different materials, but let's understand a little bit about the technology. What happens if you mix different plastics together? So there is a concept called Gibbs-free energy. So the plastics are long chain molecules. When you mix them together, there is a role of thermodynamics and entropy behavior. And luckily we have Dr. Babu. He holds 150 patents and has 30 years of experience in material science. So he has overruled the principles of thermodynamics by using kinematics. And doing this, we make these polymers homogeneous, and then we compound it to give the strength of hardwood. So our consistency, the manufacturing process and the technology is such that every piece of lumber that produces from our machine has the flexural modulus, which is the strength and the stiffness of hardwood from 6 gigapascal to 13 gigapascal, which is in the range of hardwood. And all our products are designed in that range. So this is how we consistently bring quality in our product, irrespective of what is the quality of the incoming stream. And this is our patented process and material. The second question is, how do we go to market, So, any novel material has apprehensions. Will there be acceptance in the market? What will be the price? Chalega kya? All that. DuPont faced this issue when nylon was invented. So, DuPont went to market with stockings. When it was long before nylon replaced silk. So that's the approach we have taken at Unwood. Unwood is currently not going to market as a material. We are going to market as an outdoor furniture company, a truly durable, strong materials company with innovative products for entire Indian outdoors. So that way, customer sees value. Our products are lasting outdoors. We are getting real-time feedback. We are going on improvement cycle, and we are getting a lot of confidence. With this, Unwood is positioning, and in future, once everybody knows about it, we will be happy to work with, because there is existing ecosystem of manufacturers, whether people are working with wood, conventional furniture making industry, people are working with MDFs, WPC. So these people we can do work together as franchisee, contract manufacturing, regional distribution to scale rapidly around the country. So that approach we have taken.
Absolutely, makes sense. I would say if you have it at your home, and that's when that confidence builds, and then it starts scaling, right? So lastly, thank you, Nitin, for that idea. Waste की ऐसी ही बात नहीं हो रही है. The government is also pushing on it. There are a lot of policies that are going on in the larger segments. So can I just take a minute from each of you to talk about policies that are incentivizing this?
I can start. So in the circular economy sector and the critical mineral sector, critical minerals more because it's right now tied to national security and the country's energy security and the defense security as well. Ministry of Mines has a 32,000 crore outlay to sort of fund either CapEx or OpEx in any critical minerals project in the country. They very recently, out of that, put 1,500 crores for recycling, electronic waste and battery recycling, and they've already funded 58 projects. Atera's also got one of those projects funded as well. Money has not come in, but will come. So significant amount of capital the government of India is spending. Then there is another scheme under MHI, Ministry of Heavy Industries, for making 6,000 tons of magnets in the country, for which they have allocated 7,700 crores, largely as a PLI outcome, right? So just to give you some sense, India does not make any magnets. All of them get imported from China. Last May, when China banned exports of magnets, the government of India woke up and said we need to domesticate this manufacturing, so we are not dependent on China. So 6,000 tons per annum was the target decided. Per kg of magnet produced in India, the government of India under the scheme is giving roughly 2,100 rupees as an incentive. Just from a comparison perspective, per kg of magnet sold, the price is broadly in the range of 4,000 rupees. So the government is essentially giving 60% odd of your revenue as an incentive mechanism, right? Third scheme is under METI, Ministry of Electronics, IT and Telecommunication, which is an ECMS scheme. So anything that you do, either a product or a component or a sub-assembly, which can be related to electronics manufacturing in the country, might be as simple as making compressors for air conditioners or copper tubes or anything else that you can think of, to as complicated as making chips or printed circuit boards. There is significant subsidy scheme available from METI under the ECMS scheme as well. Fourth, under Ministry of Environment, Forest and Climate Change, across different waste materials, Government of India has implemented something called EPR, or Extended Producer Responsibility. Under EPR, the thought process is that it's incumbent upon OEMs like HP, Dell, Samsung, LG, which sell these materials, to collect back end-of-life materials and make sure it's recycled in a scientific manner so that those materials can come back in the circular economy and they don't go to waste, right? So within that, there's a lot of formalization that's happening due to the EPR funds coming in, which are paid directly by the OEMs. So significant government incentive schemes are available for the sector, not only in India, but globally. In context, the US government of the last 12 months has spent around $100 billion in the critical mineral space, funding any project that is out there, right? So there is a lot of global opportunity in this space. And I think it's important that we sort of talk about that.
Absolutely.
Talking about two concerns, which are big for the Indian population and the government. One is AQI and definitely the import bill, both one of the biggest reasons for the AQI being high and fuel efficiency of automobiles being low is because 60-70% of the vehicles on the road are, they are pre-BS4, all right, so BS3, BS2 as well, so people are riding so the government is, one is mandating, enforcing a complete ban on BS4 and below, or 10-year diesel or 15-year petrol vehicles across all metros. Which is, and secondly, they are encouraging people to scrap their vehicles, and the government is incentivizing scrapping them, so that they are incentivizing by giving you rebates on the road tax, and also, a certain discount is being extended by all the OEMs like Maruti, Suzuki, and Tatas, and everybody. So if they buy back a scrap car, then they're supposed to give you an additional discount on that. So these are the incentives which are encouraging local scrap generation across, and also going forward, it could give us cleaner air and more fuel efficient vehicles, which could bring the fuel bill down.
Yeah, I think Nitin talked about extended producer responsibility. So India produces more than 4 million tons of plastic waste as recorded. Unrecorded, we don't know. And this is only going to grow with our consumption. So EPR is what people have to think what kind of recycled content they are using. And this, we see traction of people partnering with us, how government policy is helping us. Secondly, we see benefits in government tender procurement, where there is specific mention of products which are sustainable. So we have received recommendation letters from top government bodies and IAS officers recommending the purchase of Unwood products, also in schools. So we have done more than 26 schools with Unwood school benches. But then this is not only at the local level. We are seeing a global policy towards this. So Unwood has been identified by Climate KIC, which is a European body and supported by IKEA Foundation. Unwood is an uplink venture of the World Economic Forum, and they are taking us to China this month end to meet the global bodies. And we are also part of the Circular Bharat Accelerator at IIM Bangalore, which is also along with Niti Aayog. So there is a lot of push towards these technologies and support that we get, mentoring, exposure, market access, collaborations. So I think everybody's just there to help us. So it's local as well as global policy, I would say.
That's wonderful. Great. Thank you so much. I'll open the floor. I'll first give a round of applause to all three of them. Questions. We have time for 2 questions. Yes, Dinesh bhai.
Amazing. So, which part of, my question is to Nitin, okay, which part of the recycling value chain is most broken today? Collection, segregation, logistics, processing, or market linkage? And where can startups or entrepreneurs like us would like to become a kachra set, next kachra set of the battery ecosystem?
Well, given where India is, there's huge opportunity across collections, across reverse logistics or logistics per se, and across, let's say, recycling infrastructure as well. So there is opportunity across the board. But let me take a step back. Why recycling, right? Forget about recycling. Today, India is sitting at a $4 trillion economy. Our Prime Minister said by 2047, we want to become a $30 trillion economy. Assume we get to $20 trillion economy. So in the next 20 years, there's an opportunity to create at least a $16 trillion value, right? Recycling is part of it. So there are huge opportunities in the country across any space if somebody puts their mind and heart and effort towards it.
Yep. Also, I would like to say that, like you said, collection or segregation or consumption and then supply. So, wherever you can add value in whichever step will create profits for you, the next kachra set, and try to cut down logistics, So the more you'll cut down logistics, the more you'll go closer to the source, the more you will add that value closer to the source rather than bringing it thousands of miles or hundreds of miles, all right, to your own facility. This will create the maximum value for a recycler going forward. So if you're choosing something, these are the two things. One is definitely add value at any step. It will give you profits, but be as close to the source of scrap as you can be. It will give you guaranteed profits. You know.
Great. One more question, and then of course we have a long lunch, so we can ask all our questions. Ma'am at the back. Sorry, my preference will always be a woman, so I'll say that out loud.
Jai Janendra, everyone. My name is Darshana Sanjeti. So I wanted to ask, like you told, that we do scrap sorting using AI solution. So I'm just asking, what are the operational gaps that you see in circular lean manufacturing that can be solved by the AI-driven systems? The major...
Yeah, sure. So when we talk about AI-driven systems here, you know, here AI will be a combination of lasers, light, and sometimes color as well, you know, so that's fluorescent, UV rays. So it's a lot of combination here, because all the data of, you know, when segregating the multiple metals and with multiple chemistries inside. So here there's a lot of optics that is involved, one, which is, and with the data pertaining to that optics is going to help you along with other mechanical processes like pneumatic, hydraulic movements and segregating the scrap. Is that what you mean?
I was asking, what are the other, apart from the scrap sorting, what can be other operational gaps that we can solve using the AI-driven systems?
Oh yeah, of course. The you know, digitization of all these factory floors, there is so much happening in the factory. There are always, you know, areas to be digitized. IoT can be implemented, you know, starting from weighments to temperature measurements to color measurements to CCTV footage and operation steps, you know, measuring the TAT, measuring the quality or the labor efficiency, the productivity of manpower. I mean, there is so much to be done in a factory, particularly if you can, that ways it could be a great value.
Just two major gaps, if any one of you can mention.
Just to add to what Rajat was saying, right? Archana, right?
Darshana,
sorry. So just to add to what Rajat was saying, Darshana, see, AI is an overused buzzword today, right? So for the time being, keep that aside. Let's talk about automation, and AI is part of automation in some form or fashion, right? Essentially, the ideal vision should be any shop floor should be a dark shop floor. What I mean by that is no human involvement, right? To achieve that, automation can start from, like Rajat was saying, as simply as, let's say, movement automation. Can we automate all our movements, right, as a first step? Whether that requires your trolleys, whether that requires as sophisticated robotic arms or robots or whatever that might be, right? Or start from conveyor belts all the way to robots. That's the automation range that you're looking at from a movement standpoint. Next comes to the fact that anything that requires measurement and a decision and an action based on that measurement can be a chemical process. Like in our case, for example, when we talk about battery recycling, there are cobalt extraction, cobalt refining setups, there is lithium precipitation setups, there is copper refining setups. In each of these, there are control parameters basis which something needs to be done. All of them can be automated by sensors, okay? As simple as sensors. Then third, any manual work, for example, in our case, there is some sort of dismantling that happens, right? Those can be automated by robotic arms and vision. Why do you need vision for that? Because robotic arms need to self-correct if a new thing comes in, okay? So bunch of automation, any of these automations is possible across any shop floor, with the ideal shop floor being no human involvement.
I'll just add to what Nitin said now. AI comes from data. Data comes from sensors. Yeah. So in recycling industry, he said start from sensors, collect data, then comes AI. So jumping to AI won't help. Lot to do in sensing and automation. Yeah. And just quickly want to let everyone know we have a small stall outside. If you want to experience Sunwood, do go and touch and feel the material to understand how we are doing it.
100%. Thank you so much. Sorry, we have to proceed to lunch, but thank you so much. Another round of applause for all three of them, and thank you, everyone. Thank you.